Yeah, I'm Jana Cox. I'm a PhD candidate at Utrecht University, and the title of my talk is Rotterdam Digging Its Own Extinction. Well, that's a question that I'm hoping with the research I present, all of you will come up with your own answer for, but I'll also tell you my answer at the very, very end. Quick overview of how I'm going to go through everything with you. I talk a lot about sediment budgets, so I'm going to start by explaining what a sediment budget is. Then we're going to take a look at the current state of sediment, and then the long-term development of the Rhine-Meuse Delta, and then having a look at what the future is going to look like. So just to clear some things up as well, I'm a physical geographer. So for me, the new waterway is part of a big system, and that system is the Rhine-Meuse Delta. So it's basically the area that I'm showing on the map on the screen right now. So I'll talk a lot about the whole system and less about specifically the new waterway, but you'll see it plays a pretty big role in how the system is working at the moment, and it has done in the past. So what's a sediment budget? So a sediment budget basically means we combine the amount of mud and sand that is moving around in the channels with the amount of dredging that's going on. So in this case, we have 4 upstream rivers that feed sediment into the system. And then at the coastal boundary, we also have sediment exchange of sand and mud. And basically, the amount of sand and mud combined with the amount of dredging should roughly equivocate to what we see in terms of bed level change in the channels. So that's what a sediment budget is. So that's cleared up. And then I'm going to take you through a little bit about how these sediment budgets look. So in terms of the present situation for me is 2018. That's when we did this research, was in 2018. And we basically found that there is a negative sediment budget, which means there's an annual sediment loss from the delta. And for an idea of scale as to how much sediment is lost every single year, it's around 2 megatons per year, which is about 60 billion stroopwafels, which is quite a lot. And the primary cause of that is an intensification of dredging. We have seen increased dredging in recent years. This shows you the dredging in the ports and in the branches of the Rhine-Meuse Delta. And you can see since around 2012, we've had a kind of significant increase. And since 2019, with the channel deepening, we had a decrease and then again an increase. So there's an intensification and an increase in the amount of dredging that's been happening in the last decade. And there are basically 2 main reasons for that. The first is that the deep new waterway basically traps a lot of fine sediment. It traps fine sediment that's coming in from the coast, but also what's coming in for the rivers. And the second one, which I'm going to explain a little bit further, is that the circulation due to the tides is causing erosion of tidal crosscut channels. And I'll point out and explain what those are in my next slide. But basically this eroded sediment is being pushed into the port and harbor areas and needs to be dredged. So essentially what we have in this system is tides that are out of phase. We closed off the herring fleets, which is the part in the south, and we've left the new waterway open to the tides. So you have tides that are out of phase, and that's leading to what we call a tidal floss effect, which basically means that we have a significant and serious erosion in the channels that connect the 2 estuary mouths. So that's the Dordtse Kiel, the Oude the Noord, and the Spouw channels. They're seeing a lot of erosion and scouring in the last decade. And basically under normal tidal conditions, all of that sediment that's eroded is sort of pushed and driven north into the new waterway. So that means that it has to be dredged out. And that's where you see this increase in dredging material in the most recent decade. So these tidal floss effects, the tides being out of phase, that basically leads us to a circulation issue and really uneven distribution of sediment that is there. So in the north, we have all the ports and we have the new waterway, we have a lot more sediment and there's more dredging going on. In the middle, we have pretty significant erosion, which is causing bank instability and scour holes and bed degradation, which places infrastructure at risk, so underground cables and tunnels and things like that. And then in the south, we also have intertidal areas like in the herring fleet that won't be able to maintain their elevation because of the distribution of sediment, because of our circulation. So how did we get here? I'm now showing you 2 maps. So the one on the top is a map from 1573, and that's the first accurate map we have of the area. And then a map of the present, so 2020. And you'll see some pretty significant differences through time. Firstly, I just want to mention as well, for this part of the research, we basically divided the system into two estuaries. So the Rhine, the main course of the Rhine in the north, that's that blue, and the main course of the Meuse, the Haringvliet branch in the south. Just that'll come back. So the blue and the pink, if you can try to remember those. But I think the most significant thing you see between these two maps is, of course, the very, very narrow mouth that we now have thanks to the digging of the new waterway. So you can see there's a huge difference in the mouth area. So basically what we decided to do was do analysis based on maps. So this is a GIF of 40 different maps that we used. So we used geological reconstructions from Peter Voss and the Atlas of the Holocene for the Netherlands. And we also used historical or old maps. So that's what you're starting to see now with various colors, various accuracies. You're going to see some changes in the system through time and also differences within the maps. And these maps come from the Utrecht University Library, where we have a repository of old maps that have already been georeferenced. So we also had experts come in and analyze the maps, tell us how accurate they were. But these maps are basically used as the input for all the analysis that we do, where we reconstruct what the estuary would have looked like 3,000 years ago. We're now getting to around the period where you're going to see the new waterways dug. There it is. And you can see in different maps as well, it changes location in the beginning until they've tied it down. And then from around 1920, things pretty much look the same. So what does that mean? This figure shows you what the estuaries looked like in terms of their depth and their width through time. As I mentioned, the blue is that part to the north where the ports are, and the pink is the Haringvliet to the south. And if you look at the top part, part A, you can see the estuary depth through time, and you can see that the Rhine Meuse, the one to the north, that starts to get deeper over time, whereas when the delta works get implemented, you start to see shallowing in the Haringvliet. And then in terms of estuary width, as soon as humans start to get involved around 1250 AD, you have a significant shallowing. So basically where the port is, the estuary gets deeper and deeper through time, and the estuary that gets closed due to the delta works shallows through time. And both of them rapidly narrow. And to put some numbers on what that means, the Rhine Meuse since 1600 has deepened by 95%, and the Haringvliet since 1600 has shallowed by 45%. And similarly, the Rhine Meuse has seen an 85% narrowing and the Haringvliet has 65% narrowing, which is mostly due to embankments in the south. But those are pretty significant changes. So now that we know about the current and we know about the past, it's time to take a look into the future. So we made a future sediment budget for the area. And for that, we needed to know how the amount of sediment coming from the rivers was going to change. So to do that, we used a basin model from one of my colleagues, Francis Dunn. We also needed to know how the coastal sediment input was going to change. And for that, we used a very simple 1D model for sea level rise. But we also needed to predict how we thought dredging was going to change in the future. And that's the tricky part, which I'll come back to in a second. So in terms of the results from the river and coastal part, basically we saw that there would probably be additional glacier melt leading to like a small additional flux of sediment coming in from the rivers. And in terms of sea level rise will also bring in additional coastal sediment. So that sounds good because we have a negative sediment budget, but in the future, we're going to have extra sediment. So at first glance, that seems pretty good. But we also have to take dredging into account. And this figure basically shows a relation that we devised where we looked at ship size, those graphics that you can see, the pictures of the boats, that's there to scale. So the first is the very early container ships built in the 1950s, all the way up until the ultra large container ships that we have now. And we can see that as ship size increases, the channels in the Rhine Meuse, specifically the new waterway, has had to get deeper to accommodate these very large ships. So if you take this into account, basically, you might get a more extreme dredging trend than if you just project dredging based on the measured data that we have. There are some caveats to this that I do want to point out. Geology may eventually stop us deepening the new waterway. And if you want to ask me questions about that, please do in the discussion. Ship size might not also grow indefinitely. The Panama Canal basically limits how large ships can get. If they can't get down the Panama Canal, they're not going to get into Rotterdam. And also, if we start using the Maasvlakte 2 more or change the way that we allow ships in, this might be totally different. But this was the best guess that we had, so we went with it. So basically, like I said, we're going to have extra sediment from rivers and extra sediment from the coast, but we also predict there's going to be additional dredging. So that basically means this negative sediment budget that we see will continue into the future. And regardless of what climate scenario we have, dredging still dominates our sediment budget. So when we put all of that together, this table gives you an overview of all the different sediment budgets that we made. So the one for the present, that's that -2 megatons that I mentioned in the beginning. For the future, we predict 12 to 18 megatons of loss, depending on climate scenario. And then in the early period, so the geological period, the early human period, we did see volume gain of the estuary. The estuary was getting much bigger. So you saw estuary gain and sediment loss at roughly the scale we're having now. And then in the 15 to 1900s, we saw embankments, we saw volume loss through land gain, essentially. And then recently we've gone back to this negative trend. But basically, the main thing to note is that the rate of change, the predicted future rate of sediment loss that we have, and the current rate of sediment loss that we have, is the highest in the 3,500-year history of the Delta. And that is including the fact that we only make those changes in a vertical direction, because we can't make changes in a horizontal direction anymore due to the dikes. So I want to point out, and this is where I might answer my question, is it digging its extinction? Yes, maybe. But I also really want to point out that it is not alone. This is really a global trend that we're seeing. So this shows along the bottom a whole series of different estuaries and deltas. And we found a pretty nice trend. So the first part shows you where the sediment budget shifts due to dredging, and the second part shows you where the sediment budget would shift due to sea level rise in the future. And basically, we know that big mega deltas, like the ones in Asia, they're going to face their biggest threats due to sea level rise, whereas most European estuaries are actually facing more land loss due to the way we're managing and doing sediment management in our estuaries and deltas. So you have these mega deltas of Asia and a lot in South America as well, where you have a very high sediment feed, which means they can do a really large range of dredging and it won't have any effect on their sediment budget. But sea level rise really provides a significant problem. But for us and most European and American estuaries and deltas, they already have a much smaller area with a much lower sediment input. So if we do high amounts of dredging, we are kind of placing ourselves in a dangerous zone. So I suppose to answer my initial question, yes, but we're not alone. And I'm very curious to also hear your thoughts after this research on the answer to that question. And that's all from me.
Thanks, Jana.